Python's exception system is crucial for managing runtime errors. It begins with understanding the hierarchy, where all exceptions inherit from the base exception class. Key classes include exception for most errors and specific subclasses like value error and type error. Mastering try-except blocks and custom exceptions enhances error handling, ensuring robust and maintainable code. Python's exception handling system is designed to detect, report, and manage runtime errors efficiently. It uses try-except blocks to catch exceptions, allowing developers to handle errors gracefully. This system ensures that programs can recover from unexpected issues, maintain stability, and provide informative feedback to users, enhancing overall software reliability. Exceptions in Python signal unexpected events during execution, like division by zero or missing files. They prevent abrupt crashes by allowing interception and handling, ensuring robust error management. Proper handling enables programs to log errors, provide feedback, and maintain stability. Python's system offers detailed error information, including the error's location and call sequence. Base exception is the root of Python's exception hierarchy, providing the foundation for error handling. All exceptions, built-in or user-defined, inherit from it. It offers methods like *rr and repar for representation and debugging. Avoid catching base exception directly. Instead, catch exception or specific subclasses to prevent intercepting critical system exceptions. The Python exception hierarchy starts with base exception, branching into subclasses like exception, system exit, and keyboard interrupt. Common errors such as value error, type error, and I/O error fall under these branches. This structure enables flexible error handling, allowing you to catch broad categories or target specific exceptions based on your program's requirements. Syntax errors, like missing colons, are detected during parsing and prevent code execution. In contrast, exceptions, such as zero division error, occur at runtime and can be managed with try-except blocks. Understanding these differences is crucial for effective error handling in Python programming. Python's exception hierarchy is structured with base exception at the top, followed by exception, which is the parent for most user-defined and built-in exceptions. Common exceptions like arithmetic error, lookup error, and value error derive from exception. For custom exceptions, inherit from exception to maintain integration with Python's hierarchy. Special cases like system exit and keyboard interrupt inherit directly from base exception. The exception class is the main parent for most user-defined and built-in exceptions, inheriting from base exception. It excludes system-level exceptions like system exit, keyboard interrupt, and generator exit. Most exceptions, such as arithmetic error and lookup error, derive from exception. Custom exceptions should inherit from exception or its subclasses for proper integration. Python's built-in exceptions are categorized to address specific error conditions. Arithmetic error includes floating point error, overflow error, and zero division error. Lookup error covers index error and key error. OS error encompasses file not found error, permission error, and timeout error. Runtime error includes recursion error and not implemented error. Syntax error involves indentation error and tab error, while value error addresses Unicode error and its subtypes. The detailed exception hierarchy chart reveals the relationships between Python's exception classes. The OS error family is notably the largest, highlighting the complexity of file and system operation errors. Grasping these hierarchies allows for precise exception handling, ensuring errors are caught at the right level of specificity. A zero division error occurs when a program attempts to divide by zero. The traceback provides crucial insights. It shows the file and line number where the error happened, the call stack detailing the sequence of function calls, and the exception type with a descriptive message. Start reading from the bottom to trace the error's origin. Mastering the try-except mechanism is crucial for writing robust Python code. The try block contains code that might raise exceptions, while the except block handles specific exceptions. The else block executes if no exceptions occur, and the finally block always runs for cleanup. These patterns ensure error management and maintain code reliability. The try-except block in Python is a robust mechanism for managing exceptions. It includes 4 clauses: try, except, else, and finally. The try block contains code that might raise exceptions. The except block handles specific exceptions. The else block executes if no exceptions occur, while the finally block ensures cleanup operations always run, maintaining resource integrity. Handling multiple specific exceptions in Python ensures robust error management. Prioritize specific exceptions like zero division error and type error before general ones. Use separate except blocks for clarity and employ tuple syntax to catch multiple exceptions. Access exception details with as-e. Avoid bare except clauses to maintain precision. Finally, ensure resource cleanup with the finally block.